This one's probably for Ben since you're not here. 15-2. Hope you're having fun speaking Spanish. And Leah. Sorry, Leah. Hope you feel better soon. So, when we talk about an arithmetic sequence, or arithmetic sequence, what does arithmetic mean? When you hear arithmetic, how do you identify what kind of math that actually is? What?
How do I identify it?
Yeah.
Google. When there is a common difference between the terms.
Yeah, a common difference, which can either be a difference increasing or a difference decreasing. So to train for a 10-kilometer race, you guys are aware that the entire 8th grade team is competing in the Columbus Marathon, right?
Yeah.
The entire 8th grade
Are you doing
team.
it?
No, I don't run. I run when chased.
So they put a bear out there.
Yes, that was the joke when we went to Maine. My brother-in-law's a runner and he runs 10Ks. He was like, "Hey, do you want to run this 10K with me?" He said, "I run when chased." He said, "Well, we do live in Maine." He's like, "There's lots of wild animals."
That's fair.
Okay, so to train for a 10K, you decide to start with running 4K, which is, anyone know what a 5K really is in miles?
3 points.
A little over 3. So this is going to be a little under 3 miles. Since it's 4K, you're going to be a little under 3 miles. So you start training 4K on the first day. Then each week after that, you'll increase the distance that you run by a fixed amount. And you only have 10 weeks to train. So by week 9, you want to be running a 10K. So how many kilometers should you add each week to complete your chart? So how do you think we can figure this out? What do you mean 8/10? Why? Like, what thought process made you? Jacob?
So to get from week 1 to week 9, you would have to add this common difference 8 times.
So what are we looking for here? We're looking for an increase, but what's the increase? What would the units be on the increase? Kilometers. Because I'm not just talking kilometers, I'm talking the kilometers I'm going to increase in a fixed amount of time. Greg, do you know?
I think I have the answer.
I don't want just the answer. I want to work us to the answer. If you're increasing, the distance amount is kilometers, and the time amount is week. So we really want to look at that common difference as being the amount of kilometers that you're going to increase per week. So, how many weeks do we have to get to 10 kilometers? 8 more weeks, right? Because I'm already running 4. So I've got 8 weeks to increase by how much? 6 more kilometers. So, we could simplify this to 3/4. So, let's think this through. This would be 4 3/4. I'm going to skip weeks because then this would be 5 1/2, and that's easier to think about. Every 2 weeks I'll increase by 1 1/2. So then this will be 7. 2 more weeks in week 7 would be 8 1/2. 2 more weeks in week 9 would be your 10K. So what you want to do when you're looking for a common difference is determine what's the difference actually talking about. Like, what are the units going to be? And that unit or rate unit is going to tell you what math to do to get there. So I'm noticing a lot of people not writing anything down. I don't think this is solved out in the notes, is it?
No.
So if you could, at least write down kilometers over weeks, and then that we did 6 over 8, and that simplifies really to 3/4 or 0.75 if you so choose. All right, this is real goofed up. Might have to move the fan. I don't know where it is. I mean, if you want to move it to the front, you can.
Actually, the room feels okay now.
I think they finally got the heat turned off. I don't know that they have the air conditioning turned on yet, but the heat's off. Move it a little bit to the
Can you
mic.
point it just at me?
He's like sticking ready for his face.
All right, we good here? Questions? Makes sense? so
In this
when we're
problem,
looking at
you will identify
arithmetic,
arithmetic
what you really
sequences.
wanna have on those
Part A
notes
is the sequence 3,
is
6,
common
9,
difference.
12, 15, and so on. An arithmetic sequence
An arithmetic sequence shows me a common difference between terms. So if you just want to write common difference, that's okay, but what we're really talking about is common difference between each term. From one term to the next, that difference is going to stay the same. What if it wasn't arithmetic? What's the other kind of consistent change that we might see? Instead of a common difference, we might have a common... Ooh, what do you mean by factor? Who said factor? Similar ratio. Yeah, common ratio. I know that you said factor. But so we'd either have a common difference, and it's arithmetic, or if we have a common ratio, it's geometric. So we're going to talk about geometric next week, geometric sequences. But so common difference is arithmetic. Just always remember that arithmetic is addition, subtraction. That is your most basic math that you learn in elementary school. Arithmetic is addition, subtraction. Really mainly addition, but. So your key concept here shows you how we actually find that common difference. Oh, we'll blow this up a little bit. So say that we have our sequence. We've got A plus D, D being our difference. The next term will have the original term plus 2 of that difference. The next term would have the original term plus 3 of that difference. And we work from there. Any questions on this key concept? Does it kind of make sense? You really just want to say, what are we adding? And then we can work backwards if we see the sequence, which is where our example was different. Like our start example was different because we didn't see the terms of the sequence. We saw the first and the last, and we knew how many terms were in between. So this sequence, we see the terms. We see 3, 6, 9, 12, 15. We should easily be able to identify that difference as we build up is a difference of 3. So that is going to be my common difference. How would I write the function of this? Okay. Yeah. So we could say like an A sub n statement. What do you think, Greg? This is yours if you want it.
A1.
So we know our A1.
And then you would just do.
So here's the place where. Ooh, I think you're trying a little bit too hard. So up here, this A, where I mean it's on your paper. That A, we really want to make that our A sub 1, our first term that we know. So we know the A sub n, we're going to start at 3 and add, Robert? We're going to add 3 every time, and that gets multiplied by n minus 1, because the second term will have only added 3 once. So that's why this is n minus 1. Yeah?
You can really just do a sub n equals 3.
Yeah, because my difference is the same as my beginning term, yes, but that doesn't normally work. Because actually writing it, a sub n equals 3n, hey, Jacob, here's your problem. If you write a sub n equals 3n, is that an arithmetic? Is this arithmetic? Is it adding something consistent every time? This, actually, this series, this sequence, can be arithmetic or geometric. No, sorry. What I just said is not true. It's not. It can't be geometric. Do you need to move? So, if you are bugged out by whatever may or may not be happening, just move. Yeah, it's easier that way. We would have to have that consistent multiple. So I get what you're saying. Your 3n, since that would be the number of terms, that wouldn't make it geometric since it's just number of terms, but still it's a multiplier. We want to show something with a common addition. That's one of those weird cases in math where you're right, but that's not what we're looking for. But in most practical applications, that would be totally fine because it would work. All right, so what do you think here? I see 1, 4, 9, 16, 25. Yeah. So.
It's not
Not arithmetic. So what you want to look at here is this is plus 3. This is plus 5. This is plus 7. This is plus 9. But then if I look at my level 2, my increase in my increase is staying consistent.
How would you write that?
It
Or
would
are we
just
gonna
be
learn that
a sub n equals n squared.
I was sorry, I was going to come back to you. If we really analyze this, when we see that my layer 2, my change in my change, when we see that's consistent, we know it's either quadratic or exponential. So we see, actually here, this is just the n squared. So that would end up being an exponential graph, right? It's going to get bigger and bigger and bigger and bigger. But it's easy here if we think of first term, well, 1 squared, and that throws people off the 1. 1 squared is 1. So always remember that. When you see a 1 to start, that is 1 squared. Did you have something else to add, Jiggy? So the real answer here is no. It's not arithmetic, but we can write a function rule for it. So what about this sequence? Robert, what?
I found like the
You found a formula? What do you think it is?
a sub n equals
2n minus 1.
2 times n.
So 2 parentheses n minus 1. Which, by the way, if you're speaking math, what do we say for parentheses?
Sum of n. No, the difference of n.
When you're grouping things together?
Open parenthesis, close parenthesis. No, don't you just say like the 2 times the difference of n in 1?
2 times the quantity.
Quantity.
N minus 1. When you group things together, you're looking at that as a quantity. So let's test this out.
No.
1 minus 1.
It's not working at all.
1 minus 1 is 0. 2 times 0 would be 0, and my first term already falls apart.
For no, for a
But where is that incorporated in here? Are you saying like I need to like add 2 or something?
no a like a so
Okay, I know. A sub 1 equals 2, but what you gave me doesn't work. No, because if I plug in my first term, 1,
yeah plus 2
so that would be 0 plus 2. My second term, 2 minus 1, that works, but then 3 minus 1, 2 times 2, 4 plus 2 is 6. This still doesn't work. Yeah? 2 to the n power, well, 2 to the first, 2. 2 to the second, 4. 2 to the third, 8. 2. How did you figure that out? Because my common ratio here is multiplying by 2, and we're going to look at this on Monday, but because they keep multiplying by 2, all I really have to say is, well, it's going to be 2 to the power. Now, it gets a little funky if it doesn't start with 2. Say it started with 3 and then doubled every time. Yeah.
I was thinking of like previous term 2 times the previous term.
Oh, so then it would be 2 times a sub n minus 1.
Yeah, I was trying to say that.
So what Robert, I guess, was really trying to say is a sub n equals 2 times the a sub n minus 1, and that minus 1 has to be sub as well. Yeah. So that doesn't really look great, so. Yeah, that would then work.
Yeah, that's what I was trying to say. That would work.
So this, again, though, is not arithmetic. Hello. All right. So now, when we have first 2 terms, and we're told it is arithmetic, we can always refer back up to here to check out how do I write my explicit definition of an arithmetic. Start with your first term. Find your common difference, and that's going to multiply by n minus 1 because the difference only starts as we move from the first term to the second term. So if we didn't do that n minus 1, if we accidentally did n, we'd always have one too many of the difference. So when we come down here, what's my common difference in this sequence? 5. It's given to you on your notes. Common difference is 5. So I'm going to use this formula, which is down here also, but always refer back to your key concept box if you need to. So a sub n is going to be, what's my first term? 6 plus the n minus 1. Common difference? 5. And you can put the 5 in front of the parentheses if you want. There's no difference there. But
I see what you did there.
What did he do?
I said you can put the 5 in front of the parentheses. There's no difference there.
Last button.
Oh yeah, you should try to get a job for CNN News.
Actually,
Those are great.
Greg, you may not be aware. The reason I am DJ Hudcap is I was radio. I was a radio guy in college.
You were? Can you talk super fast?
No. Do you listen to the radio? Okay, those commercials have been sped up. People talk at normal speed and they speed up the track. That is not some skill that people acquire.
Wait, so
Are you guys serious? You thought people just trained them.
Mr. Hudson! Wait, hold up. Mr.
Our
Hudson.
next generation is doomed.
Mr. Hudson,
Yeah.
you're saying Ash card like shows when they sell stuff. The
No, that's an
person in real
auctioneer.
life is sped up.
That's an auctioneer. That's different than somebody who works on the radio or those radio commercials. that we do.
Yeah, why did it? Yeah, exactly.
Okay, moving on.
Hudson, you're wrong.
How do we figure out a common difference if I don't have two terms that are next to each other? How do I figure out a common difference when I don't have two terms next to each other? So I've moved 1, 2, 3 terms. So I figure out the difference is 100 minus 82, which is 18. That is going to be divided by the fact that we've gone 3 terms. So we're saying this common difference must be 6. Since my first term is 100, to write this out as an explicit rule, start with your first term, 100. Now I can say minus instead of the plus because I'm getting smaller. My difference, I'll just go ahead and put that first, 6 times the n minus 1.
So can you put these 6 in? Yeah, you can still put 6 in the back.
And you could do n minus 1 times 6. It wouldn't make a difference. Then we can actually expand this out if we want to. Like, that's just how we start writing it. If we want to simplify this, negative 6 times n would be negative 6. Negative 6 times negative 1 would actually be plus 6. So this would actually become a sub n equals 106 minus 6n. Because think about it. My first term is 100. So if I start at 106 and say at term 1, I have to subtract 6 already. That gets me my first term of 100. I subtract 6 times 2, so really subtracting 12, gets me my next term, all that. So what are my second and third terms here, really? Right? 94, 88. Any questions up to this point? The arithmetic sequences are pretty simple because it's just we're looking for addition or subtraction, and we know it. So now we get into the difficult ones where they're like, you know, what is the 1072 term?
We do the
Are they
same
really that
process
difficult?
Well, not that difficult, but they seem like, oh my gosh, I can't go that far writing them all out. So we gotta use the explicit. So, common difference here? 2. Try this on your own. Take a second. Figure out what's the 46th term here. Take a second to do it on your own. What's the 46th term here? Make sure you don't just have the answer right out the formula too. Because a big part of this being what identify what is the rule, like the function rule. What's that? They're right here, actually. Okay, sure. By the way, guys, I've left in the notes for the sub that he should give you guys all graphing calculators for the test tomorrow, and that he has to collect them. So you cannot leave the room with one of those graphing calculators.
Okay.
Yeah, I told him some kids have their own, but if he gives you one, he needs it back. Or he or she, whoever it is. I don't know. There was nobody assigned the last time I checked my ASOP page.
Do you know what's
You okay?
Kale's just
I
made.
don't know. I kind of
Why,
want
what?
to get that guy.
You know what's really unfair? Male people pants have pockets that can fit like inflatable chairs and 80 calculators and thermoses of coffee, but female people's
Okay.
pants usually don't have any pockets.
I can agree but disagree. Trendy, stylish male pants now are ridiculous. Like they are just like female pants where they don't. I like bought a pair of pants, got home and realized the pocket wasn't even big enough to really fit my whole self in it. And I'm like, I hate these now. I'm gonna donate them. Yeah. So yes, we do finally sympathize. Because of style, we sympathize. All right, who's got my my function rule here? Somebody I haven't talked to yet.
Me.
I talked to you like 9 times. Raider,
Oh my gosh, you're so
what is it? Hey guys, I can't hear when you're talking over him, especially when you're doing that. Sorry, go again. 1 plus 2n. So I'm gonna back us up and say a sub n was my first term of 3 plus 2 times the n minus 1. But that expands out to 2n minus 2, which is how Alex got a sub n equals 1 plus 2n. So my 46th term is going to be what, Alex? Anybody?
Oh, I got the answer for it also.
Okay, just give me the answer real quick then. 93, you said?
Oh, we use this for the problem with we use this.
Oh, the summing, the 1 to 1,000? We wouldn't really need to. You probably could, but that's not really like a sequence you need to figure out. We know they're sequential integers, and the difference is 1. So you could, if you were looking for like a term in that sequence or like a sum maybe in that sequence, we wouldn't really use this just for like the story problem I told you guys. So did you have something?
Would you just do 2 a sub n equals 2 times n plus 1?
2. Hold on. 2 a sub n equals what?
No. A sub n
Okay.
equals 2 times n and then plus 1.
Uh.
Not n plus 1. It's different. Yeah.
So yes, yes you can, because Seth identified, well really these are just the even numbers, except not, they're the odds. I can just find the even values and add 1. So that, which is another way to look at it, but if we use our explicit formula from the beginning, we still get the same thing. Now, the arithmetic mean. What's mean? Mean? Average. So, our teacher teacher I had, I think in elementary school, that told us how to remember that is the average teacher is mean, which was funny because you always think they are. So, what we can see here is what's the difference to jump from 15 to 59, Grant? 44? But is that the difference for the sequence? No, what would be the difference for the sequence then? Yeah, we have to divide by how many terms we've like jumped. So here I've jumped 2 terms, so my difference is really 22, which means that my value in here would really be 37. Then if I add 22 more, I get to 59, which is exactly what I wanted. I know, I told you guys, arithmetic sequences are fairly easy. So we found the common difference by taking the difference between the 2 terms divided by how many terms? Now again, I don't like that the got it always seems like exactly the same. So again, we've jumped 2 terms, but remember that if you went more than 2 terms, you'd have to divide that difference that you have by the number of terms you've jumped. These are 132 and 98 respectively. So Wyatt, do you know what we do here?
You subtract 98 from 132.
What'd you get?
Like the finalizer?
No, what'd you get for that subtraction?
34.
34. Now, are we going to talk about that 34 as a positive or a negative? A negative, because this actually went down from the 9th term to the 11th. So what we see is as we're progressing up the sequence, my values are getting lower. So now what'd you do?
Divide that by
We divide that by 2 because between 9 and 11, that is 2 terms away. And we get negative 17. So we can take 132 minus 17 to find out a sub 10 here, the 10th term, will be, say 115. Yeah.
I think it's easier to just go the other way, make it positive, and add.
So the other thing we can do, really happy you said that, is just look at it the other way around. If I was coming down my sequence, down quote unquote, we're actually going up. So then we could have thought of it as a positive 34, could have thought of this as a positive 17, and just said 98 plus 17 gets me to that 10th term. So either way, we can make it happen. And actually, I do like that method, Seth, better because addition always seems easier than subtraction. Okay, remember, easy is relative. So we're in a stadium. Maybe you go down to Schottenstein and you start counting chairs because, well, you're bored and that's what you do. So the number of seats in the first 13 rows of a section in the arena is an arithmetic sequence. You'll find this a lot of places that are like bowls or things like, especially on the ends, like back here in these sections. These are going to expand as they go up because you get wider and wider and wider, just like a track. It gets further as you go out the corner or the rounded area. So rows 1 and 2 are shown here. Row 1 has 14 seats. Row 2 has 16 seats. We want to figure out how many seats are in row 13. So what is my arithmetic difference here? Leah? 2. From row 1 to row 2 was a plus 2. So I can set up my a sub n is going to equal my first row, 14, plus that common difference of 2 times n minus 1. And now I can solve a sub 13, 14 plus 2 times 13 minus 1. 13 minus 1 is really 12. 12 times 2, 24. 14 plus 24. A sub 13 would have how many seats in it? 38.
And because there's a question on the homework I was curious about on turning into explicit. I tried the method with these.
On the math patterns homework from last night?
Yeah.
Let's get through the got it and we can look at that.
For things that are like that, where you're only like counting up by a couple, wouldn't it be easier just to formula and all that?
So one thing that you could do, like if you're trying to just jump your way straight to the answer, be careful because especially on the standardized test, they're going to want to see how you got there. So, look, this is not my decision. If I was writing the standardized test, they'd be different. But you could just say, okay, how many rows are we changing? Well, from 1 to 13, we're going 12 rows. How many seats do I gain every row? 2. So 12 times 2, 24. Add those to the first row. I mean, you can reason it out in your head the same way that the formula lets us do it. So yes, kind of, to answer your question, really yes to what you said. But make sure you understand the process for when it said, like, how many seats are in the 72nd row? Then that's really annoying. So then we might as well use the formula. Number of seats in the first 16 rows of curved section of arena are an arithmetic sequence. Row 1 is 20. Row 2 is 23. My arithmetic difference here is Anyone? 3. So if we set this up, a sub n is going to equal my first row of 20 plus
3
3.
to the what is it?
Starts with Q.
Quotient.
Nope. Quantity of.
And minus. Well, no. Oh, okay, you did.
Yeah.
Okay,
Now I'm going to go ahead and simplify this. 3 times the negative 1. This is going to get 17 plus 3n, which is going to be a lot easier to solve. So then when it asks me how many seats are in row 16, I can just say a sub 16 will be 17 plus 3 times the 16. 3 times 16? 48. Thank you. Plus 17? 65. Does this make sense? Good deal.
Formula.
The G homework had 54 problems on it. Totally not doing that.
Is there like
Thanks,
6?
Mr. Hudson.
This has like 20. 23 to be exact, but these should be really quite fast.
Yeah, I'm really close.
Sorry, bud. Give me a
Like,
second.
look, it's
Get
written
everyone
on
else
my
to hold
paper
some. I'll look
here.
at that.
You don't have to count since I was like 4. I was busy today. I have more practice.
Okay,
counting.
Mr. Hudson.
Hold on.
About number 4.
Hold on.
Add 3.
I wanna know what the
Yeah, I know.
answer
That's why it's
is.
the K version.
Wow, number 1, geez.
What is it?
Have like a concealed comment.
Hey, where'd your .05 come from?
It's
What about number 7?
It's not .05. It's .5.
Oh, Leon!
Small mistake.
Leon, you made me work through all
Small
of this to only
mistake.
find out that you messed up the entire problem.
So, after this lesson, we're just done with math for the year, right?
Yeah.
Clearly.
Nope. I've learned that I can't even be sarcastic.